this video I'll be explaining to you the rule of writing the formula and rule of naming the coordination compound. The first one is rule of writing the formula. Okay, so in my previous video also I have explained you a little bit about that. Suppose this is the complex. Now this is the cationic counter ion. Okay, so all the cations will be placed on the left side of the coordination sphere and all the anions will be placed on the right side of the coordination sphere. Okay, or we say coordination entity. Now suppose if there are more than one type of ligand, okay, say like this. In such cases we place the ligands first according to the alphabetical order. So here Cl, C comes first, then N. Okay, between C and N, C comes first in the alphabetical order. Therefore, we place the Cl first, then only NH3. Okay, NH3. Say suppose this is the ligand. One is NH3, then the other one is NO2. Okay, so here in this case, see NN same. So therefore we check out the next letter, that is H and O. Okay, in this case H comes first according to the alphabetical order. Okay, then O comes later. Therefore NH3 is placed first, then only NO2. Okay, now moving on to the next one, that is rule of naming the coordination compounds. So the first one is naming of the ions or the counter ions. Okay, K2CN6. In this case, see how we name it. Okay, first is the counter ions which are outside the coordination sphere. If it is cation, okay, cation will be written first. Here we shall not write dipotassium. Okay, we shall name it only potassium. So cation will be named first, then comes the name of the coordination sphere, name of the coordination entity, then comes the anionic. Okay, but before the anionic, an oxidation state of the center metal atom also should be mentioned. Now in case of naming the coordination entity or coordination sphere, okay, first we shall name, okay, the ligands, then only name the center metal atom. After that comes the oxidation state. Okay, now the next one is, suppose if there are more than one type of ligands in the coordination complex or compound, then we shall name it according to the alphabetical order. Okay, we shall name it according to the alphabetical order. Now the next one is naming of the ligands. Ligands are also three types, that is anionic, cationic and neutral. If it is anionic, okay, if it is anionic, it will end with letter O. If it is cationic, it will end with ion, and if that particular ligand is neutral, okay, then it will be acidic. Okay, no change in name. So say for Cl minus, it will be chlorido. If it is fluorine, it will be fluorido. Okay, and so on. Oxalate means oxalato. Okay, then Am means nitrosonium, nitronium. And for neutral ligand like thiourea, okay, thiourea and so on. Then moving on to the next one, that is a numerical prefix. If more than one ligand of the same type is present, then, okay, if two ligands of the same type is there, then we give it di. Okay, if it is 3, tri. If it is 4, we name it as tetra and so on. Okay, now if in that particular ligand have already the numerical prefix di is being used, say for example En. Okay, En is ethyl 1,2 diamine. In such cases, since di is already used, so if the number is 2, okay, I mean 2 ligands, if 2 ligands are there, then we give it as base. If it is 3, okay, these are the numerical prefixes. If it is 3, then it will be 3s. If it is 4, it will be tetrakis. Okay, then only we write the name of that particular ligand in a bracket. Okay, now ending the name of the central metal atom or ion. If the net charge of the complex is anionic, so these are the anionic complexes. Okay, these are the anionic complexes, or maybe like PTCl4 minus. Okay, these are the anionic complexes. In that case, we end the name of the central metal atom with 8. Okay, so this one will be ferrite, this one will be platinate. Okay, this one will be platinate. So this is how we name. Then let us try one example. Okay, so one example is like COCl NH3 5Cl2. This one, the net charge of the complex or the complex is a cationic complex. Okay, cationic complex, because a counter ion, which is anion, is neutralizing the complex. Now the name will be like this. Okay, this is chlorido, this is amine. Okay, double M. A comes first, so therefore it will be pentaamine chlorido. Okay, and since it is cationic, so it will be as cobalt, and oxidation state it will be -1, -2, -3. Transfer that side, it will be +3. Okay, in terms of Roman number. Then we end with this anion, that is chloride. Okay, so this is how we name it. And do not forget to find out the oxidation state. Okay, do not forget to find out the oxidation state of cobalt. So X plus -1 plus 5 into 0 plus -2 equals to 0. Okay, so X -1 -2 equals to 0, X equals to +3. Okay, so that way the oxidation state of cobalt is +3. Let me give you a few examples of problems you can try out by yourself. Okay, so the first one is KPTCl4 NH32. Okay, the first one. Then the second one is CO NH34. Okay, Cl2. So this is the second question. Okay, you can try these two questions, and one more is here. Say suppose Fe Cl NH33, okay, minus, or maybe say plus, you just take it plus. Okay, now remember that if there is any charge like this, okay, then after the end of that particular name you end it with ion. Okay, so these are the 3 problems that you try it. Okay, and let me know.